So some of you might be having some flashback. Well, hopefully all of you are. So we're going to be doing the notes today, just a quick podcast, no commitment to the time, I'll be honest. The key for pages 7 and 10 are up front that you should be checking it. Oh, Mrs. Gross, do you want to actually kind of go by and just stamp or see if they actually have it done? They probably are going to try to talk you out of it, but if you just want to kind of go by, I have stamps in my right hand cupboard and you can actually go by and check to make sure they have those worksheets done. That would be awesome. Then once she's done that, you guys can check the work. If you have any questions, you can ask when I get back on Tuesday. Okay, let's talk about moles then. So this is at the top of page 11. Again, we've used this. You used this when you did the aluminum foil. Let's do a quick refresher. Remember, a mole is to a chemist as a dozen is to a baker. You all know that if you want a dozen donuts, you're going to get 12. If you have a gross, that's going to be 144 objects, not 144 subs though. So what we have to know that is just the mole to us is a counting that we use if we want to go in to know how many atoms you have or how many elements. Okay, it's how many particles. Where you need to add something, somewhere in your notes, probably up there at the top, add some vocab. Because if you want to have 1 mole of just an element, let's say it's going to ask, what is your mole, how many moles, how many atoms do you have in 1 mole of carbon, sodium? Then this is going to be 6.02 times 10 to the 23rd. We're going to label it an atom. So this is where the vocab, if you have just an element, you call it an atom. If you have 1 mole of 2 or more, or a compound, or even diatomics, then you would have 6.02 times 10 to the 23rd molecules. That is a U, molecules. That should be a U. Okay, this is for a covalent compound. Same number, look at all the differences vocab. Well, a new word we might be seeing a little bit more, if you have 1 mole, again, of a compound, but it's ionic, then you would have still 6.02 times 10 to the 23rd, but it's not molecules. What we call them are formula units. Watch your abbreviations when you're doing formula units. So what you have then is you know it's the same number, we just define it differently. Well, we can do the same thing if we have different amounts of dozens. I can have a dozen roses, I can have a dozen eggs, I can have a dozen donuts. You know that a dozen is 12. So same things with us, what a mole. Okay, vocab that also comes different. If you have a molecule, we can break it down further. I could ask you molecules, and then I could ask you in that molecule, how many atoms do I have? And we're going to do a sample of that. Same thing. If I have an ionic compound, which means, again, they're formula units, I could break down and ask you how many ions do you have as you go through this. So remember that a mole is our counting. Okay, the reality is we don't use it that often. What do we use more is your molar mass from the periodic table, because that is more realistic. Because if I say, let me see, I can't even remember who I have. Sorry, this is horrible. Whoever's out there. Jessica, go get me a mole of carbon, please. Everybody should have your periodic table out. If you need to pause and get out your calculators and periodic table, then go ahead and do that. But you look at the periodic table. You should know that a mole of carbon is 12.01 grams. So if you massed out 12 grams, you would have a mole. And so if you look at it, let me get to where this, so right here. So this is saying if you have 12 grams, you know you have a mole, so then that means you have 6.02 times 10 to the 23rd. Well, I could ask somebody else to go get a mole of iron. and they would have to mass out, what is it, just about 55.5 grams. I'm kind of rounding. I don't have the periodic table in front of me. So that means that iron would be 55 grams, but even though it's more mass, it still has the same amount of moles, 6.02 times 10 to the 23rd. You could go get aluminum. 26.98 grams would equal 1 mole equals 6.02 times 10 to the 23rd. Now remember that when you're also doing it, you can have the molar mass, when we're converting, where's that? The molar mass, that's you have to add it up. So I kept saying, okay, you guys all know the molar mass of water. Well, remember, this is 2 atoms of hydrogen plus 1 atom of oxygen. So on the periodic table, you take 2 atoms of hydrogen, so 2 times your 1.008 plus 16. This is where 18.0 grams per mole. Okay, if you had sodium phosphate, remember all this naming, this will be coming back. That's going to be next. Sodium phosphate. Sodium phosphate has 3 sodiums, plus 1 phosphorus, plus 4 oxygens. You just take that, add it all together. That's the molar mass of that compound. So this is where you have to be really careful of oxygen. Because if I look and say, okay, I need a mole of oxygen. So to get that mole of oxygen, you would have to remember, oh, oxygen is one of my 7 diatomics, so therefore the molar mass of oxygen is 32 grams per mole, not 16. That's for an atom, but all diatomics will be double their mass. Okay, so this is why I'm kind of looking at it. Even though they all have the same number of atoms, they have different moles. No, excuse me, same number of atoms have different masses because each individual atom is different. Just like if I had a dozen golf balls and a dozen bowling balls, they would not have the same mass because each individual item has a different mass. Exactly the same thing with atoms. So we use molar mass for a conversion. When you need to go grams to moles, moles to grams, you use molar mass. Okay, let's look at some other applications we can use with molar mass. And this is kind of another application of definite proportions. So just kind of add this and say, again, you're going to have to add some notes. Now we need the back. I'm going to add onto that problem, but you can use the bottom part of the back. Let's do this problem. So if you need to kind of pause it to write it. So calculate the mass of sodium in 15.5 grams of sodium chloride. Sodium chloride, remember, NaCl. So this is saying I know that the whole compound is 15.5 grams, but I only have I want to know just the mass of the sodium. So I need to know what percentage is sodium. There's different ways we can do this. This is showing you one way. Let's use percentage. Because the law of definite proportions said they're always going to be in the same ratio, the same percentage. So I'm going to use the molar mass. So the molar mass of sodium chloride is 58.44. Take the mass of 1 sodium plus the mass of 1 chlorine. So I want to know what percentage is just sodium. So out of that 58.44, 22.99 grams is sodium out of the 58.44 grams of the whole compound. Remember, percent is part over whole. We'll just leave it as a decimal. This is 0.393. You should be working these on your calculator. If you need to pause again so that you're seeing where these numbers come from. Well, the percent of chlorine, okay, 2 ways. You could do the same mass and say 35.45 divided by that, or you can subtract, because you know the rest has to be, since there's only 2 things. And so you know the mass that's coming from chlorine would be 0.607%. So then it's just a percentage. If I have 15.5 grams, you know out of that 15.5 grams then, you know that only 0.39% or 39% of it is, so just take 0.393 of your 15.5. So that tells you 6.09 grams is actually sodium out of that 15.5 grams. And that's again with the law of definite proportions. I don't care where I get that sodium chloride from, you know it's always going to be in that ratio. So you know that 39.3% is always going to be sodium as you go through it. Now this you have at the bottom there. This is just what we're going to be doing really the rest of the year. And to be honest, we don't use this one that much. We stress sometimes in the 6.02 times 10 to the 23rd, we use it when you see the words atoms, molecules. The reality is we just don't use those in the lab. You're going to use 22.4, yeah-ish. PV equals nRT more. Okay, definitely where we're going to use it a lot more. This, you're going to use it, in fact, in the lab we're going to do next week. This, all the time. You're getting ready to go back in the back right now and do some problems using molar mass. These are the two most important ones, using molarity and using molar mass. That's what you're going to see over and over and over again this year. So, let's kind of practice. I want you again, you can pause, write this problem. These are really good to have part of your packet because, again, when I'm pulling questions for tests, it's things that I know that we've done before. Okay, this one, guess what? No calculators. Mrs. Gross, make sure nobody gets to use their calculator. This is fair game for a multiple choice question that you can use, that you could be doing to have no calculators. Okay, so look at what we have. Okay, probably even in the beginning, I'll give you the formula. Calcium plus 2, fluoride minus 1, so you know it's calcium fluoride. So calculate the number of molecules, which is formula units, but I went ahead and stayed with the molecules, and 11.1 grams of calcium fluoride. So you know you have 11.1, and remember, you have to go from grams to moles. You have to mole it. We turn moles into a verb. Who knew we could do that? But you have to mole it. And then you can go to formula units or molecules. I don't care if you call it formula units or molecules. I just wanted you to see that word, so if you saw it, you didn't freak out. So this is how many grams I have of calcium fluoride. Okay? And then you have to turn it into moles. So 1 mole of calcium fluoride, look what I have here. 101, that was nice, grams. So this is where mental math comes, because remember, on the 60 multiple choice, you do not get to use a calculator. This could be a question on a multiple choice, and you're expected to answer this without a calculator. So what happens if it's a question like that? You need to find the relationship. They're not going to make you do some long, crazy division. You're going to have to see a relationship. So if you look at this compared to this, okay, if you had the decimal here and you moved it this way, they're the same number. This means you have a tenth of a mole. I'm hoping you can see that and recognize that's what you need to look at. A lot of times you have half of a mole, a tenth of a mole. You have a quarter of a mole, 0.25. You have 2 moles, 5 moles, 10 moles. Look for a relationship. So then if I have a tenth of a mole, you need to multiply this number by a tenth. So if I'm taking this and multiplying by a tenth, am I affecting the coefficient or more the exponent? So remember, if you're multiplying by a tenth, means you're dividing by 10, you're affecting the exponent. The exponent is just going to decrease by a factor of 10, so you'd have to the 22nd molecules. There's your answer. You just did a mole problem without picking up the calculator. Yes, I expect that you can do that. Okay, and then guess what? We're going to step it up. We're going to say, okay, yay, molecules. Again, this is formula units. Now I'm going to say, okay, this could be another question. Instead of saying how many molecules, I could say how many fluoride ions are in 11.1 grams of calcium chloride. Okay, so if this was an individual problem, we could start from this beginning again. But if I already done the molecules, then I'm going to start from there. And remember, this is just asking you to count. If I was able to draw, let's say, calcium fluoride, you would have a calcium, remember, and this is saying you have 2 fluorides for every one you have. Okay, calcium is made up 1 calcium, whoops, and 2 fluorides. Okay, so if I look at this, this is right here is saying that you have 3 formula units because you have 1, 2, 3 formula units. This would be like if I said, hey, how many cars do I have out there in that parking lot? We could probably do a math and figure rows times columns and figure out how many cars. And I say, awesome. Oh, wait, I now need to know how many tires do I have. So do you have to go out and count each individual tire if you know how many cars? Hopefully most of you are going, duh, no. Because you know one car has 4 tires. So you would just take however many cars you have and multiply it by the amount of tire, or say forever how many cars. If you had 100 cars, you would say, well, every one car, and we could set it up, and you would say, well, one car is 4 tires. So take your cars and multiply them by tires, and that's how many tires you have. You're doing exactly the same thing. We're just dealing with a number that's so incredibly hard that sometimes you let that freak yourself out. You're doing the same thing. It's just counting. So in this individual, I know in one molecule of calcium fluoride, you have 2 fluoride ions. We just draw that. This is one molecule, 2 fluorides. So that says, to answer this question, I'm just going to take your number that you had just calculated. And again, if this was all one question, we would just add one more track. And you say you have that many molecules. And I know then for every one molecule you have of calcium fluoride, there are 2 fluoride ions. So you're just going to take this number and multiply it by 2. Again, no calculator. You can do this without a calculator. So when you're just multiplying it, it affects the coefficient, and it'd be 18 times 10 to the 22nd. Okay? But it won't be like that most of the time, because that's not how you do the significant figures. We need to have one number. So that means the answer then you would see is 1.8 times 10 to the 23rd molecules. And somebody say, well, how did I get that? Well, how did you go from 1.8 to 18? You had to multiply it by 10. This has to increase by a factor of 10 then, going through it. Okay, this type of problem, expect to see in multiple choice. Okay, fair game. You can do it without a calculator as you're going through it. Okay, this is our last practice we're going to do together. This is the one, remember, on the back of your packet. We did problem 1 last time. This is when we calculated the percent. We had to do simultaneous equations, or a system of equations, sorry, whatever we call them. And we calculated the percentages. And I can't remember my numbers. Uh-oh, my fault. I think it was like 69, oops, 69, put whatever numbers are the correct numbers, so your mathematically should be your numbers. And it was 69%-ish, I know it was around that. Copper, 63, and so then we had, it was like 69.4 or something. So whatever your number was here, I know that that's not exact, put in exactly what it should be. Okay, we're going to use this information. So look at what number 2 is asking you. It's saying calculate the number of copper 65 atoms in 15.5 grams of copper. Okay, this should look a little bit different. The reason this is different, notice right here, this is the huge thing. Okay, I'm not just asking you the number of copper atoms. I'm asking you specifically about one isotope. And this is where chemistry, one other way, gets a little difficult. What this is a sample of copper. We have taken a copper sheet, and I have the ability now to supersize. We have an electronic microscope that we can now see. So what this is telling you is 69% of the sample is going to be a copper 63, and 30%-ish, again, is going to be your copper 65. So that means if the red are my copper, atoms, those are all my copper 63 atoms. Those are all in there. Well, at the same time, we have copper 65 atoms are existing in this sample, but you only have 30%. So there's a lot more copper 63 in a sample of copper than there is copper 65. This is what an isotope is. It's a perfect blend of the two atoms. Perfect blend, but not in perfect proportions or in equal proportions there. So this is the problem. Okay, but this is saying it's 15.5 grams of copper. So this is of actual copper, not just of copper 65. So there's not a shortcut. You can't just use the mass. I can't just use this mass. That doesn't work for this because this mass has copper 63 also in it. So you're just going to have to use the molar mass of copper from the periodic table. So from the periodic table, 63.55 grams. Okay, I know that that's copper. That's pure copper. And then I can say, well, I know that for every mole of copper, there's going to be 6.02 times 10 to the 23rd atoms. Okay, now this is where we're going to say, okay, but I know that only 30% of those atoms are actually copper 65. So this is where I would say, well, only though every 30, again, put in the actual number that you calculated, atoms are copper 65 out of every 100 atoms of copper you have. Again, that's what a percentage is telling you when you're going through it. Now this problem is not a mental problem. This problem you pick up the calculator and you crunch the numbers to see what you get. And that's what I'm doing right now. So that's what you're doing right now, is crunching those numbers to see how many you get. Okay. I got as an answer, okay, 4.41 times 10 to the 22nd. And this, what is this? This is atoms of copper 65. Whoa, not sure where it went. Of copper 65. Okay, so that's some of the samples that we're going to be doing. We're still going to be practicing next week. So next week we have the lab. One day is going to be lab. One day is going to be review and more problems with that. And then the test is looming coming up. But we've pretty much covered all the problems. So now we're just going to keep practicing and kind of focus on the lab. So you have a mole activity that you're going to be doing. And then when you finish that, you can be working on that pre-lab. But you have all three different types of mole applications that you're going to do. Assume the aluminum is pure aluminum. Okay, I know there's writing, I know all that. We're just doing it as a process. The salt, there's beakers up there. They're not labeled, but it's white, it's crystal, it's salt. Just take the mass of the whole sample. There's weigh boats. And then you have water as you're going through. Hopefully you remember the density of water. Google it. If you don't, ask somebody else. So those should be due. Now if you need to finish it over the weekend, you can do that and it won't be late, but you really should have enough time in class that you can get it. So if nothing else, make sure you have all the data that you can finish it. And then you're working on pre-lab, so you don't have any more problems in the packet to work on. Like I said, we'll be finishing those next week too. Have a great weekend, and I will see you guys next week.